Okay, hi students, welcome back to my YouTube channel. I have already uploaded 3 videos in which I have completed the probability and statistics part of 2019 A-level paper. And in this video, I am going to take the previous question of statistics and probability, which is 16th question. So it's all about center of gravity. Okay, so without further ado, I'm not going to explain any theoretical part. I'm directly going to jump into the question. Okay. Right. Now I have my past paper with me. So let me read the question and do from the beginning. So 16 question. I hope you might have your past papers with you, right? So you can read along with me and you can just observe how I'm explaining the question. After that, you can try the question by yourself. And if you struggle, you can rewatch the video and you can practice to obtain a good results in your A-level examination. Okay. Right. Now show that the center of mass, number one, a thin uniform semicircular wire of radius A is at a distance 2a by pi from its center. So you might be familiar with the proof of this center of mass of different shapes, right? So this is nothing. So I will just directly prove it. Okay, a thin uniform semicircular wire of radius a. Right. Now let me take a coordinate axis. This is y and this is x. Right. Now I am going to place the uniform semicircular wire on the coordinate axis like this according to symmetry. So along x-axis this wire is placed symmetrically. Okay. So when I start writing the answer, this is what I have to write at the beginning. By symmetry, okay, by symmetry, the center of mass, okay, by symmetry, the center of mass or gravity lies on x-axis, or otherwise if I take this as origin or x-axis. Okay, right. Now after that, what I have to write is I have to take a representation for mass per unit length. Okay, so this wire has a length. Okay, so per unit length I have to take a symbol. So rho, let's take rho is equal to mass per unit length. Right. Now what I am going to do is I am going to divide this wire into small tiny pieces, and each piece's mass is going to be integrated. Okay. So I am going to, let me take like this. I am going to divide this into small pieces. So let me take this as theta and this portion is delta theta. Okay, I hope you can be able to see the letters that I am writing over here. Anyhow, you can manage, I think. Okay, right. Now I'm going to take this piece, the mass of this piece. So delta m will be equal to A into delta theta. Okay, so mass per unit length. So the length of this piece is A into delta theta. You know, right? So this is obvious. Into, so this is the length of this piece, and if I multiply by rho, I will get the mass of that length. So rho. Okay, so this is the mass or the mass of this tiny piece. After that, what I have to write is x bar. Okay, because x bar. Okay, by symmetry, the center of mass lies on x-axis mean. So here it will lie on this x-axis. So along y-axis it is symmetric, right? So the y bar, so y component will be 0. That's what it means, right? Now x is equal to integration of, okay, I can take x length into dm divided by integration of dm. So L whatever. Right, now in this case what I am going to do is x of this small piece is what? A into delta theta. So the length of this small piece is A cos theta. Okay, so this length x is equal to A cos theta, and I have to integrate from minus pi by 2 to plus pi by 2. So integrate minus pi by 2 to plus pi by 2. A cos theta into dm. So if I put integration symbol, this delta m will become dm. So that is obvious. You have already studied in the theory part. So I don't want to explain with reasons, right? So a cos theta into dm. So instead of dm, that is delta m obviously. A into delta theta. So a, when I put into integration, delta will become d theta into rho divided by okay, right, divided by again dm is equal to minus pi by 2 to pi by 2, right? Dm is this portion, a into d theta into rho. I have just written this one. Now if I simplify this one, so what are the constants that are inside the integration symbol? This a, and this rho. So I can take them out. And again here we have a and rho. So I can eliminate this and this. So only a will remain here. A minus pi by 2 cos theta divided by minus pi by 2 here d theta into d theta is also here. So I'm going to write this one here. Cos theta, integration of cos theta will be sin theta into a into sin theta divided by pi by 2, the limit is pi by 2 to minus pi by 2 into theta pi by 2 to minus pi by 2. Right. Now if I substitute the values, so a into sin pi by 2 is 1, again minus pi by 2, so it will be 2, okay, yeah, and here 2, a into 2, here pi by 2 minus into minus pi by 2, that will be pi by 2 plus pi by 2 will give you pi. So the answer would be 2a by pi is the answer. So this is what they have asked in the question. So show that the center of mass of a thin uniform semicircular wire of radius a is at distance after this distance from the origin. Okay, so from the diameter of this semicircular wire, it lies, or the center of mass lies after this distance. Okay, in the second part, I hope you have understood this one. So let me erase this. Right. The second part, a thin uniform hemispherical shell of radius a is at distance a by 2 from its center. So the second figure that we are taking here is a hollow hemisphere or semisphere means it's like a coconut shell. Okay, right. It's like a coconut shell. So let me take a coordinate system. This is x and this is y. Okay. Right now this is going to be hemisphere. Okay. So this is a and this is also a. So like this. Yeah. Radius a. Now radius is a, and we have to prove that the center of gravity lies at the distance of a by 2 from the diameter of the hemisphere. Okay, so let me take it as g. Okay, so you have to write the same sentence. The gravity by symmetry, the center of gravity lies on x-axis and so on. Right? I will just write down the x component. X component would be equal to. Now for that, what I have to do is I have to chop this hemispherical shell into slices, thin slices like this. Okay, so it will be like this. Now I measure theta from here. So this will be delta theta. Now if I chop this hemispherical shell, I will get small pieces like this, like a ring. Okay, right. Now let's say this is A means the radius of this one. Radius, okay, now if I take this small piece, the radius of this one here will be, this is A, right? This is A. So this is A cos theta and this is A sin theta. So the R is A sin theta. Okay, right. Now what I have to do is, this is also the same, x into dm. So x means this total length. The total length would be A 2 pi. So normally you know the circumference of a circle is 2 pi r. So the r is 2 pi A sin theta. Okay, so that is what we have to write. And x is equal to, here the length, this x is equal to A cos theta. So you normally write like this, x into dm integration, and here integration dm. This is not necessary in the examination. So x is this length. So x is this length. And dm is delta m. So you have to write. So let rho be the mass per unit length. Not unit length. Here the area. Okay. Here the area. Rho should be equal to mass of unit area. Okay. Right. Now delta m should be equal to. Now we have 2 pi A sin theta. So that is the length or area into rho. So delta m is equal to 2 pi A sin theta into rho. So I just substitute the value here. So x is equal to integration. I have to start from here. So if I slice from here, so starting from here, I can slice up to this point. Mean I have to integrate from only for this perpendicular. I mean that 90 degree. So from 0. So if I measure the angle from here, 0 to pi by 2 only. So here you don't need to put minus pi by 2. You will end up with wrong answer. So the limit is 0 to pi by 2. Okay, so when I chop it, so earlier case from here I was chopping, right, like this, slice, I mean small thin pieces. But here I am chopping the shell. So it will be, the limit will be 0 to pi by 2 only. Right. Now here instead of x I can put A cos theta into here delta m would be dm, that is equal to 2 pi A sin theta into delta theta into rho. So you can directly write this one. So 2 pi A sin theta into rho into d theta divided by, you just write this one, not 2 pi by 2, 2 pi A sin theta into rho into d theta. Okay, right. Now this is also very simple. So what are the constants that we have here? Here 2 pi A will go, and here we have A cos theta sin theta. So cos 2 theta. Cos 2 theta means if I integrate it, that will become A into sin 2 theta by 2, and the limit is pi by 2 to 0 divided by, here sin theta is remaining. So my sin theta, in the sense it will become cos theta. Okay. Yeah. Okay. So sin theta means minus cos theta because integration. So pi by 2 0. Okay. Right. Now just substitution. So sin pi by 2, it will be here sin pi by 2. So sin pi is equal to 1. So A by 2. Here we have sin cos pi by 2. Minus cos pi by 2 means 0. Then cos 0 minus into minus 1. So it will become 1. Okay, minus 0 minus 1. So it will be 1. So the answer would be A by 2. Okay. So is the answer correct? Yes. A thin uniform hemispherical shell of radius A is at a distance A by 2 from its center. So this is the center origin. So from its center, the center of gravity lies at the distance of A by 2. So we have proved. Okay, now these are the questions that comes under direct theory part in this unit, and we will move to the next part of this 16th question. Right. Now, a spoon is made by rigidly fixing to a thin uniform hemispherical shell. So they are going to be talking about the shells that they already given to prove, right? So the semicircular wire and hemispherical shell. So these two objects are going to be used to form the compound object. Right. A spoon is made by rigidly fixing to a thin uniform hemispherical shell of center O and radius 2a, a thin handle ABCD made of uniform wire consisting of a straight piece AB. Okay, now we have in the spoon the handle is made up of two components, a wire and a straight line. Okay, straight line or straight what do we call piece, straight piece AB, length 2 pi a and semicircular piece BCD. Okay, let me sketch the diagram here for easiness. So this is like this. Okay, now this is the spoon. I have roughly sketched the diagram. This is DCB. DCB. This is A and this is O. And they are telling this is A and this is A. This is 2A. Okay, this is 2A. And this length, the piece of the stripe, the stripe portion of the spoon is 2 pi A. So this is 2 pi A. And what else they are telling? Okay, in addition to that, they have given the mass per unit area of the hemisphere is sigma. The mass, okay, that is sigma. Mass per unit area. So we have to find out the area and multiply by sigma. You will get the mass of the total hemisphere. And mass per unit length of the handle is A sigma by 2. So for this portion, that is A sigma by 2. Okay, very simple. Now show that the center of mass of the spoon lies at distance below OA. So below OA, y bar is given. Y bar is equal to, we have to prove 2 by 19 pi into 8 pi minus 2 pi squared minus 1. Then x bar is equal to a distance from OD. So from OD, x bar is equal to 5 by 19A. So this is what we have to prove first. Right. Now I have denoted all the data given in the diagram in the question. Right. Now I have to put a table. So let me put this table. Okay, so let me take figure or object, whatever. Then mass, and then distance of mass of gravity from OD. And now I'm going to take this as the origin. Okay, right. Now if I put here, so this is y-axis and this is x-axis. Right. Now from this origin, at what distance the center of gravity of each component of the compound figure is lying. Right. Now I'm going to take this one, right? This one. So you can just write like this. Otherwise, you can write the name as well. So the mass of this one is, the length is, this is hemisphere, semicircular wire. So 2 pi r. So pi r. So pi a is the length of this one. Pi a is the length of this one. into A sigma by 2. So that is equal to pi, yeah, pi A square sigma by 2. Right. Now, okay, distance of center of mass from, okay, now from let's take OD means in this direction along x-axis, from OD in this direction. So again, distance of center of mass from this one OA along y-axis, okay, from OA in this direction, I'm sorry. Okay, right. Now the second one is, okay, for that, okay, now if I consider this one, that is equal to, from OD it is lying, okay, symmetrically after A, so this is A, and from OA, from here, now we have already proved that the center of mass of a semicircular wire lies at a distance of A by 2, yeah, not A by 2, 2A by pi, 2A by pi from the center, of the wire. So here 2 pi A plus, and the center of mass is 2A by pi. We have already proved this one, 2A by pi. Right. Now the second figure that I am going to take is this straight one. Okay, this one. So the mass is 2 pi A into what? 2 pi A into the mass per unit length is A sigma by 2. A sigma by 2, that would give you pi A square sigma. Okay, and from OD, the center of gravity of this straight wire will lie at the distance of 2A, right? Because it is fixed after 2A from the y axis. So that is 2A. And from OA, so this, since this is a straight line, so it will be in the middle of the straight line since this is uniform. So that is pi A, right? So that is pi A. Okay. Now I will take this hemispherical shell. Right. Now that is what? So that is 4 pi r square. So for a sphere, the area. So we have been given unit mass per area. Mass per unit area. So the area of this hemisphere is 4 pi r square means 2 pi r square into sigma. Okay. Now the area of this hemisphere is 8 pi r square. So 8 pi a square, right? I'm sorry. 8 pi a square. So unit, this is area, and this is what sigma is. Mass per unit area. Mass per unit area is sigma. If I multiply the area of the hemisphere by sigma, I will get 8 pi a square. Okay. Right. Now the total figure. Okay. Now from here, the area is 0. Here, yeah. Okay. From OD, the distance of the COM, I mean the center of mass is 0, and from here, this is okay. Now we are measuring from OA, and it lies below OA, so minus, and we have already found out that is A by 2. But okay, now A by 2 for a hemisphere with radius A, but here the radius is 2A, so this is not A by 2A. So you should be very careful while doing the question. If you put A by 2, you will not get this answer, and ultimately you will be stressed, and you can do the next question also. But this is very simple. Okay, right. Now what I have to do is I have to take the total one. Now pi a square sigma, this one is this one this. Now if I add this, I get 19 pi a square sigma by 2. So this is this one. This is the spoon. Okay. Now this is x bar and this is y bar. Now what I have to do is I have to take moment with respect to moment about the origin. So moment about the origin. If I take moment about the origin, the moment about the origin of the compound figure will be equal to the summation of the moment about the origin of the figures in the figures individually. Okay, so which means you know how to write the equation. Okay, right. Okay, now so 19 pi a square sigma by 2 is equal to into x bar is equal to, now this component will be 0. This component will be 0 and this component will be 0 and this one pi a square sigma into 2a plus this one pi a square sigma by 2 is equal plus into a, I'm sorry, into a is equal to, now if I simplify this, I'm just simplifying this. Okay, what are commons in all the terms? So pi a square sigma is common, pi a square sigma is common, pi a square sigma is common, and this 2 is common, this 2 is common, so this 2 will become 4. Okay, right. Now 19x bar is equal to 19x bar is equal to 4a plus a. Now from this I can tell x bar is equal to 5a divided by 19. Okay, yes, I have obtained the first component. Now I have to do the same thing for this one also. So let me erase this one. So you can, so since I am uploading the videos on YouTube, you can pause the video and write down. Okay. Now here again, so this into this is equal to this into this plus this into this plus this into this, that's all. So 19 pi a square sigma by 2 into y bar is equal to this into this. So minus a, I'm sorry, 8 pi a square sigma into minus a, okay, minus a plus this into this pi a square sigma into pi a, okay, pi a plus this into this pi a square sigma by 2 into 2 pi a into 2 pi a plus 2a by pi. Right. Now I have to simplify it. If I simplify it, okay, so you can simplify at your own risk. So I will get 19 pi by 2 y bar is equal to minus 8 pi plus 2 pi a plus a. Now after that I have to obtain this one. So for that I have to, that's all, y bar is equal to 2. I bring this 2 and 19 pi into this one will be written here. So I have obtained this answer and I have to take a also outside. And with that, with the, okay, I'm sorry. Right, with a, so when I bring this to, okay, 2 over 19 pi minus, so I can get minus also outside, 8 pi minus 2 pi minus 1. So this minus indicates that the center of mass, I mean the y component of the center of mass, this the entire figure lies below OK. That's all. Okay. So you don't need to bother about this negative symbol. That's all. So I have done this portion also. Is there anything else to explain? Okay. Now if I explain you how to simplify this one. So pi a square sigma is common here. 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 So 19. Okay. Right. Now here I have pi. So if I bring this pi here, right? If I bring this pi here, 19 pi by 2 y bar, and this minus 8a should be multiplied with the pi. So minus 8 a pi. Okay. minus 8 a pi, and this portion also will be multiplied by a pi. Okay, so yeah. Yeah, and I can eliminate this two, and this pi. So yeah, so pi. Oh, 2 pi square a should be there. Yeah, I'm sorry. So this is 2 pi square a. Okay, so simplification is doesn't matter. I have explained it, and you can simplify. Okay, you might have done a lot of simplifications. So 2 pi, because if I multiply this pi with this pi, so I will get 2 pi square a plus a is remaining here. Okay, a is remaining here, and this pi will eliminate this pi, and here also we will have pi. Okay, so ultimately I get this as the answer. Now I will move to the latter part of the question. For the latter part of the question, they are telling, okay, a spoon is placed on a the spoon is placed on a rough horizontal table with the hemispherical surface touching it. The coefficient of friction between the hemispherical surface and the table is 1 by 7. So they are telling mu. Okay, let me erase all these things. So where is the position of the center of gravity of this one? So I obtained from OD, that is 5 by 9. So positive means in this direction, and let's say that is here. So this is G. Okay, this point is G. Right. Now continuously they are telling mu is 1 by 7. And show that the spoon can be kept in equilibrium with OD vertically by a horizontal force applied at A in the direction of OA. So at A we are going to place a force. So let me denote that using. Okay. Now by applying. So okay. Now in this side the spoon is overloaded by the handle. So it will tend to slant in this direction. So to avoid that, we can simply apply a force. So it will tend to tilt in this direction. So by applying a force, just by pushing in this direction, we can keep it at equilibrium. And we have kept the spoon at a rough surface. So when we keep this on a rough surface, there will be a reaction force. Let me denote it using R. And when it tends to move in this direction, so it will tend to move in this direction, so friction will be exerted on this direction. So let me use F. Okay, right. Now we know F less than or equal to mu R. If F less than or equal to mu R, you can keep the object at equilibrium. Object is at equilibrium. So this is the condition. And when mu is greater than or equal to R, okay, F over R, we can tell the object is at equilibrium. Now I have to find this ratio, F over R. Okay, now how can I find F over R ratio? Now if so I don't need this portion also. Okay. Now if I take the horizontal portion or vertical portion of the forces, we have weight here, right? So weight will be here, weight W, that is W, and W is equal to R. And if I take horizontal component of the forces, so now this is P, right? So yeah, P is equal to F. Okay. Now what I am going to do is I am going to take the top. I don't know the P and R. So if I take the moment above this origin again, I will get an equation in terms of W and F. Okay, and W will be equal to definitely R. So I can involve R and F. So take torque. Okay, take torque about the origin. So now, okay, now clockwise and anti-clockwise forces are exerting. So F into this length is 2A. Okay, so F into 2A will be equal to this is P. Okay, I'm sorry. F into 2A is equal to W into, we have found out this component, that is 5 by 19 if I am not wrong. Yeah. So P into 5 by 19A. So I can eliminate this A and this A. So F over P is equal to 5 over 38. Okay, F over 38. Now F over P is actually equal to F. Wait. W, this is W. I'm sorry. W, and here F over W. Okay, F over W. So F over W, from this I can write F over R, because W is equal to R. F over R is equal to 5 by 38. Now I have F over R ratio, right? And here 1 by 7 is there. I have to compare these two. Right. Now in the numerator I have 5, and in the numerator of the friction coefficient we have 1. So in order to compare, I should have same numerator or denominator. So if I write this, okay, mu is equal to 1 by 7, that is equal to 5 by 35. Now 5 by 35 is there, 5 by 38 is there. So when the denominator decreases, the entire fraction will increase, as you all know, right? So 5 by 38, I'm sorry, I'm writing over here, 5 by 35, 5 by 38. So which is greater? Since this is greater, so this will be less. Okay. So instead of 5 by 35, I can write mu greater than. Instead of this one, I can write F over R. Right? Since mu is greater than F over R ratio, the object can be kept at equilibrium. So that is the conclusion that we are going to write at final. Okay. So I hope you have understood this question. However, I have messed up here and there, and since this is my first video on center of gravity, and I have just explained without any pre-preparation. So I have just explained according to my pace, and I will try to explain in detail or clearly in the upcoming videos. And we will meet in another video. Thank you.